This is lesson 4.5, isosceles and equilateral triangles. The objective of this lesson is to use and apply properties of isosceles and equilateral triangles. To warm up for this lesson, we have to revise the meaning of isosceles and equilateral triangle. We've taken this from before in grade 4 and 5 and 6, and we classified the triangle based on, or the different types of triangle based on the side length, into 3 types of triangles. We said I have isosceles triangles if 2 sides are equal, equilateral triangles if the 3 sides are equal, and the scalene triangles if the 3 sides are not equal, means one side is a 3 and one side is 4 and the third side is 5. Now, our scope of the work today is talking about the isosceles, which has 2 sides are congruent, and the equilateral, which has all the sides congruent. To start talking about this lesson, we have just to make sure that our understanding for some vocabularies is ripe to start on. Now, if I'm talking about an isosceles triangle, this means I have this side congruent to this side. Okay? Any 2 sides in the triangle are congruent, I call them legs. What do I call the third side? The base. So where is my base? This is my base. As a result of these names, since those are the legs, this means I have here an angle and here an angle. Those I call them base angles. Why? Because they are formed by the connecting of the base with the first leg and the base with the second leg. So what I call the third angle, which is here in the top, what do I call it? This one. What do I call it? Vertex angle. So I have 2 legs, which are the congruent sides in the triangle, in the isosceles triangle. The third side is called base. The 2 angles in the base are called base angles, and the big angle or the top angle in here is called vertex. Now we'll start our lesson by introducing the first theorem, which is related to the isosceles triangle. The first theorem is telling you, if you have an isosceles triangle, and when I say isosceles triangle, you should expect that 2 sides are congruent. So in this lesson in here, in this question in here, or this drawing in here, CA is congruent to CB. Okay. What is the result? The result is that the base angles are congruent. Where are the base angles? As I told you, here is the base, which is AB. So these are the base angles. A is congruent to B. So if I am talking about an isosceles triangle with 2 congruent sides based on the name, this means the base angles are congruent. Where are the base angles? They are the angles that formed by connecting the base with the 2 legs. So angle A and angle B are congruent as a result of being in an isosceles triangle. We have a converse of the isosceles triangle theorem. What's the meaning of converse? It's like the opposite, not opposite in meaning, but opposite in direction. Means in the first theorem in here, this is the cause. Since they are since we are talking about isosceles triangle, the base angles are congruent. Here in the converse, I start with the angles. Since I have the A congruent to B, this means I am talking about an isosceles triangle which has CB is congruent to CA. Okay, let's see what is the use of such a theorem in our work. He's telling me, using the isosceles triangle theorems in problem number 1. He's asking me, is AB congruent to CB? AB and CB are sides. So this means He's asking me, is the triangle isosceles? I have only one way to check that the base angles are congruent. If the base angles are congruent, then I'll say that yes, it's isosceles. So let's say I will see that AB, this is AB, and CB. He's asking me about those. So where's the third side, which is my angle base, my triangle base? It's AC, okay? Now I need to see where are my base angles. This is the first base angle and this is the second base angle. Are they marked congruent? Yes. So I can say easily yes, since angle C is congruent to angle A. AB is congruent to CB by the converse of the isosceles triangle theorem. Okay, let's go to B, and he will ask me about another triangle. Is angle A is congruent to DEA? First of all, I need to make sure that you know where's the DEA. Here's the DEA, okay? Explain. Now, since he asked me to check the angles, this means I have no way but to check to see that are the sides are congruent. In another way, is this triangle isosceles with two equal legs? If yes, this means the base angles are congruent. About which triangle we're talking about? We're talking about this triangle, the small one. The DA is marked to be congruent to DE, so it is an isosceles triangle. As a result, angle A is congruent to angle E. Now, let's see the got it. The got it has two parts. The first part is asking you, is angle WVC, this is the angle, congruent to angle VS, is congruent to angle S? Since he's asking me about the angles, I need to say, is the triangle isosceles? Means, do we have a pair of the side congruent? So yes, I say yes. Yes, right? Why? Because, or since, WV is congruent to WS. This is by which theorem? The isosceles theorem. Right? So I say that the angles are congruent, right? So angle WVC is S is congruent to angle S. Let's look at part number 2. Is TR, the big one, congruent to TS? I need to check the base. Where's the base? This is my base. SR. Where are the base angles? The angle S and angle R. Are they congruent? It's not marked, but talking about the first part, we proved that angle WVS is congruent to angle S, right? And I can see from the figure that angle R is congruent to angle WVS. If I have angle 1 congruent to angle 2 and angle 2 congruent to angle 3, so can I say that angle 1 is congruent to angle 3? Yes. By which property? Yes, the transitive property. So I can say that angle S is congruent to angle R. Angle S is congruent to angle R. So TR is congruent to TS. And since this is by the converse of the theorem, why? Because I proved that the base angles are congruent, so I can say yes, it is an isosceles triangle, and the sides are congruent. Now we'll talk about another theorem which is about the isosceles triangles. He's telling me AC is congruent to BC. AC is congruent to BC. I always like to highlight the sides that we're talking about, so you make sure that what is given exactly and what's needed. If you highlight, if you train yourself to sketch in geometry, you will be able to spot the work and track your steps easier. So AC is congruent to BC, and ACD is congruent to BCD. Where's ACD? Here. Congruent to BCD. So did he speak about the base angles? No. He said that I can understand that this is an isosceles triangle by marking that CA equal to CB, and the vertex is divided into two parts, and these parts are congruent. So ACD is congruent to DCB. Okay, what is the result? The result that this line which is the CD that we draw in here, it is perpendicular and bisector to what? To the base. What's the meaning of, or what information I can get from this? I can say that since it is perpendicular, this means that the two angles in here are 90 degrees. This is 90 and this is 90. What else? That the side AD is congruent to DB. Why? Because CD is a bisector, and we took the word bisector from before, cut into equal parts. So the AD, this side, is congruent to this side. Okay? So I repeat this theorem for you. If I have an isosceles triangle with the two legs, this equal this, okay, and the vertex angle is cut into equal parts, this means this part, no, I'll use another line. Okay, this part is equal to this part. So you check your vertex angle, is it cut into two equal parts? What's the result? The result that the line in here that you can draw, it is a bisector and perpendicular. Meaning of bisector what? The meaning of bisector what? That this side equal to this side, and perpendicular means what? Means what? That this angle is 90 and this angle is 90. Okay, let's see how do we use this theorem. He's telling me what is the value of x. We always use algebra as an application for the geometry theorem. I will look in here. Before working, I need to check, am I having all the information to use the theorem that we've just explained? Let's see. He said if you have an isosceles triangle. Do we have an isosceles triangle? Yes, this is equal to this. Do I have my vertex angle bisected, or the two parts of my angles from the vertex here are congruent? Yes, he marked with one line and one line. Okay, what does this give me? What do I do? He said as a result of this, you can say that this side is congruent to this side. But he didn't ask me about the side, so I don't need this information. At least in here. He told me as well that the two angles in here, which are formed by this bisector, are 90. So, using the angle theorem in the triangle, or the sum of angles theorem in any triangle, I can say that the sum of the three angles which are in here, this and this and this, should be 180, right? Now, if I have that the angle A is 54 and angle ADB is 90, so I can say that the first angle, which is 54 plus 90 plus, since this is x, so this is another x because they are equal, angle x equals 180, right? And I can add them together, 90 and 50, 144, yes, 144 plus x equals 180. This means if you just move the 144 to the other side, x equals to what? 36, right? So I made sure first that I can apply the theorem. The theorem, you have two steps to check it. First, that you have an isosceles triangle. Second, that the vertex is, or the vertex angle is bisected into two equal parts. So this angle equals this angle, right? And then you use the result that this side, which is BD, is a perpendicular and bisector. We didn't need the length of AD and DC, although they are the same, but we used the information that this angle is 90, so we added 90 and 54 plus x, 180, based on the angle sum theorem in any triangle, and we got the x equals 36. Now, he's telling me, suppose the measure of angle A is 27. Measure of angle A is 27. So let me just try to sketch the triangle for you. Okay. The first one in here is x. Let me just make it a little bit bigger. Okay, here are the triangles, and this is the bisector. This is 90. This is angle A. Let me just go back. BA. This is, sorry, B. A and BADC. DC, and he's telling me that this angle is what? 27. Okay. And this is x. Both of them are x. Because what? Because they are bisected by the BD, yes. And this is my vertex, which is B. What is the measure of x? So I can say that 90 plus 27 plus x equals equals 180. So if you add 90 and 20, it's 110, 117 plus x equals 180. If you move the 117 to the other side, you will subtract 180 minus 117. So x will be what? 63. Okay, to make sure, add the 3 and 7, 10, 6 and 1, 7 and 1, 8. So the measure of angle x equals 63. Now we finished talking about the isosceles, and we're talking about the equilateral triangle. And equilateral triangles are the triangles, as we said from before, that they are all equal sides and all equal equal angles, right? Here we have a new word, or we use it in geometry, which is the corollary. Okay, the corollary. It's a theorem that can be proved easily using another theorem. Since it is a theorem, we can use it to prove or a reason in the proof. Now, what we need from this is, here I have an equilateral triangle. As a result, the three angles are congruent. So in any equilateral triangle, all the angles are congruent. What's the converse of it? If you have congruent angles, this means you are talking about equilateral triangle. Okay? So in any equilateral triangle, all the three angles are congruent. If you are given that the angles are congruent, you can guess that the type of the triangle that you're using is what? An equilateral. Now, what do we need from this? As well, we needed to find the missing sides and angles, or to prove congruence in my drawing. The first application in this theorem in problem number 3 is finding angle measure. What are the measures of angle A and B and angle ADC? A and B and angle ADC. First of all, I need to highlight the angles. I'll try to sketch this drawing for you here. Okay, why I'm sketching? To show exactly what I need, because this is colored and it's not, or it will not be clear for me when I highlight anything. I need to put that all the sides are congruent, this equal this, equal this, equal this, to show that the three formed triangles are congruent. Okay, now he's telling me what are the measure of angle A. First of all, this is angle A, right? Since we are talking about equilateral triangle, this means the 180 is divided equally into three angles. In any triangle, the sum of the three angles in any triangle equals 180. So if I assume that this is A, or the measure X, whatever you want to use, A, X, whatsoever, you will divide 180 over 3 to get that A equals 60. Okay, so if this is 60, sorry, I erased the triangle instead of erasing. If this is 60 and this is 60 and every single 60, all of them, he's asking me about what angle? ADC. Let's highlight the ADC for you. This is ADC. Where's the angle? This is the angle, the big one. So it is made by 60 and 60. So what is the measure of angle ADC? It's 120. Okay, why it's 120? Because we are adding two angles from the two different triangles, ADE and DEC. So we add 60 plus 60 gives me 120. Now he's telling me that suppose the triangles in problem 3 are isosceles triangles. I need to sketch again to make sure that this is the third triangle. When I say that isosceles triangle, this means that this equals this, and this equals this, and this equals this. So did he tell me any information about the three sides? No. Right? If I'm talking about isosceles triangles, he's telling me where ADE, I need to put just the letters first. So DC and AEB. DC and AEB. Where the angle ADE, this is the first angle, and DEC, this is the second angle that he's talking about, and ECB, this is the third angle. What are these? Vertex angles. Vertex angles, okay? Now, if the vertex angles each have a measure of 58, so this is 58, and this is 58, and this is as well 58. What are the measure of angle A? He wants angle A, and angle BCD, which is here. The BCD, which is, I need another color. This is the BCD, the big one. So it's a sum of BCE and ECD. Okay? Now, since it is an isosceles triangle, I'm not gonna use anything about equilateral. I have that this is an isosceles triangle. Let's talk about the triangle ADE. ADE, since he asks about A, so I'm talking about the triangle that includes A. ADE, it's an isosceles triangle which has the vertex angle 58. So I will just draw ADE, ADE. This is the D, this is the A, and this is the E. The measure of D is 58. And this is an isosceles triangle, right? Okay, what's the measure of this angle? I don't know. We have a theorem related to the isosceles triangle telling you that if it's an isosceles triangle, this means that angle A is congruent to angle E, right? This means if this is X, this is X. So I will say that 58 plus X equals what? 180. This means 2x plus 58 equals 180. If you move the 58 to the other side, this means 2x equals 180 minus 58, which is 122, right? Yes. So if you solve this equation, you will get, by dividing over 2 and dividing over 2, you will find that x equals to 61, which is the measure of angle A. Okay? Okay, so we found that A is what? It's 61, right? And this means that this angle is 61. And this means, since those are the vertex angles are congruent, this is 61, and this is 61, and this is 61, and this is 61. Okay, so now if we want to use, or if we want to find the measure of the big angle, which is the BCD, it will be the sum of this is the measure of angle BCD. It will be the measure of the vertex angle which he gives me plus 61 that I got, which is 9 1, which is 911, which is 119. This is the measure of it. Now we finished the lesson in here by talking about the theorems related to isosceles and equilateral triangles. We will recall the three theorems together. If I have an isosceles triangle, this means the base angles are congruent. If he gives you the converse, means if he gives you that the base angles are congruent, this means it is an isosceles triangle. The other one, it's talking about if the vertex angle is divided into two equal sides in an isosceles triangle, this means that the line that connects between the vertex to the base, it is perpendicular, making 90 degrees, and it is a bisector. It bisects the sides or the two parts of the base are congruent. If we're talking about the equilateral triangle theorem, we have one theorem which is if it is an equilateral triangle, this means the angles are congruent, and if he gives you that the angles are congruent, this means that the 180 divided by 3, so every angle in any equilateral triangle equals 60, and this means it is an equilateral triangle, all sides are congruent. We'll solve some questions from the lesson check. We'll start by A. What is the measure of angle A? How can I know? I need to check what type of triangle I have. I have an isosceles triangle because he marked for me AB equals to CB. Since it is an isosceles triangle, this means the two bases angles are congruent, and this angle is 70 degrees. Now, if I want to look at question the error analysis, Claudia drew an isosceles triangle. She asked Sue to mark it. Explain why the marking of the diagram is incorrect. I will revise the theorem. There is an isosceles triangle, so she marked that the two legs are congruent. What is the result? That the base angles are congruent. Where are the base angles? C and B. So Claudia should mark C congruent to B. Angle C should be congruent to angle B, not angle A congruent to angle C, and this is her mistake. We will solve one question in here. For completing the statements, we complete these statements based on our understanding for the theorem. The VT is congruent to which side? I will mark VT for you. We need to see the VT, so we are in the big triangle, VTX. I can see easily that angle T is congruent to an angle X. So this is my base. So where is the other leg? This is my other leg. So I will write Vx. Why I'm doing this? I have to highlight the base to know where is the other leg, since the base angles are congruent. UT this is UT is congruent to which side? If it's congruent to YX. YX is congruent to UW, so I can say UW. VU where's VU? Here's VU. It's congruent to which side? Since UT is congruent to YX and VT, the whole, is congruent to VX, so the rest of each side is congruent. So it's congruent to VY y. Angle VYU, VYU is congruent to VUY. So I will say VUY. Since VU is congruent to VY, it's an isosceles triangle, so the base angles are congruent. And when I say this, I'm talking about this triangle. We said that the two legs here, this is congruent to this, so the base angles are congruent. Let's solve one question from the algebra. Here, question number 10. He gives me that the two sides in here are congruent. Okay, this means that it is isosceles. So if one of the base angle is 50, so this angle in here is 50 as well. And based on having the three angles in any triangle are added to be 180, so 50 plus 50 equals 100. 100 plus x should be give me 180. This means x equals 80. What about the y? If I have in the other triangle, the vertex angle is 100, so the rest of the 180 is divided into two equal parts. So I will say 80 divided by 2 equals 40. This means y equals 40 degrees. By solving these questions, we finished our lesson for today. Here are the answers of your homework. To check your work, please check after you solve. Make sure